Here we go. Good morning, everyone. Happy hump day to you. We have made it to the middle of the week. Thank God, praise God, hallelujah. Today is Wednesday, June 3rd, 2020, and we are going to be reviewing our homework, which was solving one-step inequalities. Now, if you missed yesterday's video, I will be sure to leave that link at the end of this video. The same worksheet that we are going to go over in a few moments, it is as a PDF file on yesterday's video. So again, just make sure that you watch yesterday's video, you download the worksheet and hop to it. All right. And I believe we have someone else that's just joined us. So let me acknowledge who is here. Good morning.
Good morning.
All right. How you doing, Robert? You all right?
Yes, ma'am, and yourself?
I'm trying to hang in there. Just pray my strength in the Lord, sugar. Trying to hang on in there.
I will.
All right. Well, we're going to go ahead and get started. The goal for me is to finish this video by a certain time, post it so that way you all can rewatch it if you need to and all of that good jazz. All right. So this is the worksheet that I gave you all yesterday. Now, if you don't have it on you or with you, it's totally okay. We are going to go over each one of these problems, okay? Just to make sure that we know how to graph them, how to solve them, and all that wonderful good stuff. All right, so let's see. I'm going to zoom on in here. Hopefully, y'all can see that. See these nice little problems here. All right. All right, so let's see. All right. And I'm going to pull up my toolbar. We just going to get it cracking. All right. All right, so your homework, you were to solve each inequality and graph its solution. All right, so remember, when you are graphing, you are going to either have an open circle or a closed circle, and then you have to determine which direction your line is going, because whichever way the line is going, that's going to represent your solutions to your inequality. All right, so, and that's a 7. Hopefully y'all caught that. But number one, we have negative 12 is greater than x minus 7. Okay, so I'm going to go ahead and rewrite this down here. Okay. Now, again, if it helps you to, if you still kind of like, well, I don't know how to solve this, go ahead and replace the inequality sign for equal sign. Because remember, as we stated on yesterday, you're doing the exact same steps as you would if this was an equal sign. The only difference is it's not an equal sign there. This is an inequality. So what I would have to do, because this is a subtraction problem, I would have to add 7 to both sides. Okay. Now, when I do that, of course, I know that that cancels out. And I am left with negative 12 plus 7. So who can tell me what negative 12 plus 7 is? Feel free to use a calculator if you have one. Ooh. Oh, okay. I mean, I don't know if that was the answer or not, but
-5.
negative 5. That's it. So we have negative 5 is, sorry, greater than x. All right. Now, this kind of tells me a couple of things. I do know, because I have a regular schmegular sign here, that I have an open circle above my 5. So remember, they're not always going to put all the numbers there, but we know that negative 5 falls in between negative 6 and negative 4. Now, to determine which direction my line goes in, I am going to pick a number off the number line. I am going to pick I don't know, -2. Let's just try -2. So what you would do is you would say, is -2, I'm sorry, is -5 less than -2? Is that a true statement? Yes or no?
Is -5 greater than -2?
Yes, is that true?
No.
Nope, it is
No.
it is not true. Because remember, when you are dealing with negative numbers, the number that is closest to zero is the greater number. So 2 would actually be greater, but this is not a true statement. So I'm going to give it a sad face because that's not true. So that means any number to the right of -5 would not be true. So that means my arrow is going to go to the left, and all my nice little decimals, fractions, negative, blah, 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 is going to be a part of the solution. Now, if I were to pick a number to the left, let's just say -8. So I am going to, here it is. I'm going to say -5 greater than -8. Now, this is a true statement because, again, if we look at the number line, -5 is closer to 0 than -8. So this is what will make this true, and we are going to give that a smiley face. Okay. So does everybody see how we came up with that answer for number 1?
Yes, ma'am.
All right. Now remember, if you have any questions at any given moment, just feel free to be like, Ms. Hampton, I got a question. Okay. So that's not going to change, right? I promise. All right. So let me scroll on over here. Let me skedaddle number 2. All right. Now we have -1 plus r is greater than or equal to 4. Okay, so thank God I have the room down here. So I'm going to go ahead and rewrite that. Okay. All right. So because I have an addition problem here, what am I going to do? I got to do something.
Subtract.
Mm, okay. What am I subtracting?
-1.
Ah, I'm going to add -1. So you're right, but let me show you something. And I'm glad we're doing this because I know it looks kind of funny, but remember, when you are adding any numbers, you can transpose them or switch them, and it will give you the same effect. So I could easily say R -1. Now, in this instance, you would have been absolutely right. Either way, I still would have to add 1 to both sides. But I just wanted to write that out to show you that these two things are equal. Okay. So if it looks kind of funny and you're dealing with an addition sign, now this does not work for subtraction. So don't try it with subtraction because it's something totally different. You can go ahead and transpose or switch them because I want to say that is a commutative property, meaning that you can switch it and it won't make a difference. I think that's the right word. But anyway. So,
Commutative property.
yeah, I think it's called commutative property. I said communicative, but y'all know what I meant for the people that's watching. All right. So forgive me. All right. So when I do that, we know that that cancels out. And I am going to be left with aura is, yes, I said aura, is equal to, I'm sorry, not equal to, it's going to be greater than or equal to because I have my line under my inequality. It's going to be 5. Now, because I have the greater than or equal to sign, which circle do I have? Do I have an open circle or a closed circle?
Open.
Open, you sure?
It's a closed circle.
Yeah,
It's a
close.
closed it's a closed circle. So remember, let me scroll back over here to number one so y'all can see the difference. If your inequality sign doesn't have a line under it, like number one, you have an open circle. Okay. Now, number two, we have a closed circle simply because we have this line under our inequality sign. Okay. So that's what's going to make it a closed circle. This also lets me know that this answer is included as a part of my solution. Whereas number one is not, -5 was not a part of my solution. Okay. So hopefully that makes sense. And if it doesn't, just let me know. And let me skedaddle back over here. All right. So which way am I going to go? So again, you want to pick a number off the number line. Let us pick, let's pick 7. Just lucky number 7. So what I'm going to say is I'm going to substitute 7 for the letter R, and I'm going to write it out like this. And is that a true statement? Is 7 greater than or equal to 5?
Yes.
So because it is, that means any number to the right, 6, 7, 8, 3,000,000, 1 point, I'm sorry, 10.39, whatever, all of those numbers would be considered true, okay? Or would make the inequality true. So any number to the right. All right. So we're going to give that one a smiley face too. And I think I heard another ding. So I just want to acknowledge if we have someone else joining us. Good morning.
Good morning, Miss Philomena.
Yes, ma'am. Thank you for joining us, Miss Philomena. We are going over the problems from yesterday, from what I sent you all yesterday. Okay, so this, I'm not going to hold you all long. After we finish this, it's going to be a wrap. All right. But again, if you have any questions, feel free to ask. All right. So we have number 3. All right. So I'm going to okay. So I'm going to rewrite it here. I have n minus 6 is less than or equal to -14. All right. So remember, you have to ask yourself, what kind of problem is this? So based on our sign, this is a subtraction problem. So what does that tell me? I have to do what?
You gotta add 6 on both sides.
I got to add 6 on both sides. Excellent job, McFadden. Okay. So when I do that, I know that that cancels out. And that's going to leave me with n is less than or equal to -8. Now, based on my inequality here, do I have an open circle or a closed circle?
Closed circle.
It is a closed circle. And again, the reason why it is closed is because I have this equal sign that's under there. So that lets me know, or that line, which is an equal sign basically. So that lets me know that 8 is a part of my solution. Now, again, we need to figure out which way this thing goes. So I don't know. I'm going to pick 10 just for the fun of it. So I am going to substitute 10, I'm sorry, -10, excuse me, -10 for the letter N. And I'm going to see if this is a true statement. So is -10 less than -8? Is that true?
Yes.
It is true. Why? Y'all didn't think I was going to let y'all off that easy, right? Of course not. Even though I'm not feeling well, I still want you to be on it. So tell me why. You're right, but I just want to make sure that you understand why. And please don't say because Miss Hampton told me so. That's a good answer. It's not the definitive answer. So
Well,
again,
the
go ahead, Mr. McFadden.
I said, what was the question?
The question was, is 10 -10 less than or equal to -8? Robert said yes. He is correct, but I want to know why.
-10. Is
Negative
it
10 is less than or equal to -8, but I want to know why.
hmm.
Okay, so
I
let's
wanna I wanna say, but I think the because it's closer to zero.
that's it.
Okay.
That's the definitive answer because -8 is closest to zero. So remember, the negative number that's closest to zero is the largest number. Okay, so this is true. So that means all of my numbers to the right. Did I do that right? Hold on. Nope, I went the wrong way. I meant to the left. Had to be to the left. All right. My bad, y'all. Y'all pray for your teacher. So any number to the left will make that true. Glad I caught that. So -9, -10, -3,000,000, negative infinity, all of those numbers to the left would make that true. Okay. All right. So how do we feel so far? We feel okay? Is it starting to click in and make sense?
I'm getting it.
Okay. I'm here for it.
Same here.
All right. Happy to hear that. All right. So we just gonna scroll on over to number 4. All right. Now, the good news is as I rewrite this, this is going to let me know what I need to do automatically. So tell me what I need to do.
Subtract.
I need to subtract. Well, it is a subtraction problem.
Need to add
No.
7 on both sides.
Yep, I need to add 7. So you were right, Robert. It is a subtraction problem. However, because it's a subtraction problem, we need to do the opposite, which is add 7. All right. So we're just going to scratch that guy out. And then our answer is going to be B is less than -5. Okay. Now, do I have an open circle or a closed circle?
You have a you have a open circle.
Have an open circle. Excellent job, Mr. McFadden. I'm going to try to make that as open as I possibly can. All right. Now, we need to determine which solutions will fall under this inequality. So, with that being said, Mr. McFadden, I want you to pick a number off the number line. Any number. I don't even care.
-1.
-1. Okay. So I'm going to say -1 is less than -5. Is that true?
Yes.
It
No,
is?
No,
no.
no, my bad.
Okay. No, no, no. I mean, no, but this is good because I want you all to catch, catch these connections. No, this is not a true statement because -1 is closer to 0 than -5 is. So we're going to give him a sad face because that's not true. So that means any number to the right would not make this true. So that means I need to go back to the left. Now I'm going to pick a number to the left to prove this point. So I'll go ahead and pick 7, -7, excuse me. -7 is less than -5 because when I compare these two numbers, -5 is the closest number to 0 than -7. So we are going to give him a smiley face and a check mark. Okay. All right. We whipping through these, so that this is good. All right. All right. Now we got number 5 here. I'm gonna go ahead and write it over here. Okay. All right. So tell me what I need to do.
You gotta add 17 on both sides.
Sure do. As the day is long. Now, when I do this, I know that that's going to cancel out. That's going to leave me with A is greater than what?
1.
1. A is greater than 1. Do I have an open circle or a closed circle?
Close.
Closed?
Open.
Well, yeah, I mean, just by trial and error and process of elimination. It has to be one or the other. So yes, we have an open circle.
Mm-hmm.
Okay. So remember, our open circle, whenever you have just a regular less than or a greater than sign with no line at the bottom, is going to be an open circle. The closed circle is when you have the line under the inequality sign. So pick a number, Robert, off this number line. Any number.
-2.
-2. Okay, let's try it. So we're going to determine if -2 is greater than 1. Is that true?
Nope.
Nope. So that tells us that any number to the left of any number to the left of 1 would not make this a true statement. So we give them a sad face. Now I am going to pick the number 2, just regular schmegula 2. And remember, when I'm picking numbers off the number line, that's going to determine if my line goes to the left of my answer or to the right of my answer. So this is just another way of checking to make sure that you're putting your lines or your direction of the line is going the right way. So we do know that 2 is greater than 1. That's what makes it true. So that means any number to the right of 1 is true. Da, 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 da. So, of course, smiley face and heart. I mean, well, a check. We'll do the hearts later. All right. Ooh, okay. Number 6 looks pretty interesting, but it's actually not that bad. I have 15 plus x is less than or equal to 0. All right. Now I'm going to write this another way. You don't necessarily have to do this, but again, I just want to show you that when you are dealing with addition problems, you can transpose or add them. I'm sorry, transpose them or switch them if it helps you to do that. What am I going to do with this problem?
Subtract
What am I subtracting?
15 on both sides.
Yes, sir. As the day is long, show is. All right. So, of course, when I do that, I am going to be left with x is less than or equal to -15. Do I have an open circle or a closed circle?
Close circle.
Very good, Miss Philomena. I have a closed circle. Oops, I put it in the wrong spot. Sorry, y'all. All right. So I'm going to put my closed circle over negative 15 because if I substitute negative 15 for x, negative 15 is less than or equal to negative 15. So that's what would make this a true statement. And that's the reason why I have a closed circle, because 15 is equal to 15 or negative 15 in this case. All right, so let's pick a number here. I am going to pick negative 12. So what I'm going to do is negative 12 is less than negative 15. Is that true?
Yes.
It
No,
is?
my bad. No.
Okay. Now, no, now, and I promise you, I'm not trying to make this a trick question or anything. But remember, that is not a true statement because negative 12, if I can find my cursor, negative 12 is closer to zero than negative 15. So this is why we give them a sad face, because that's not true. So that means any number to the left of negative 15 would suffice. Do, 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 do. La, 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 la. All right, there we go. All right. Okay, we rocking and rolling, y'all. We getting ready to get to the fun stuff next. And we're making good time too. All right. So for number 7, I have 3 plus v is less than equal to negative 9. And again, if it helps you to put your variable first, it really doesn't make a difference, but I'll just go ahead and write it. All right. So tell me, what am I going to do here?
You subtract 3 from both sides.
Sure do. All day. So I'm going to subtract 3. Okay. And when I do that, that cancels out. And V is going to be less than or equal to negative 12. So does everyone see how I came up with negative 12?
Yes, ma'am.
All right.
Yes.
All right. Miss Philomena, you still with us?
That's okay. I'm with you.
Okay. Just wanted to make sure you were still with us. All right. So I have V is less than or equal to negative 12. Do I have an open circle or a closed circle?
Close.
Why?
Because negative. Hold up.
Okay.
Because, excuse me?
Yes, ma'am. Go ahead.
Because it has a sign of greater than and less than.
Yes, because I have the equal to sign under my inequality. So that lets me know that negative 12 is a part of that solution as well. Okay. So anytime I ask that question, y'all, you can simply just say because there's a line under the inequality sign. And that's the reason why you do have a closed circle. But a more definitive answer would be what I just said, because the reason why we have a closed circle is because negative 12 is a part of that solution for this particular inequality. Now, of course, you ain't got to say it like that, but just in case somebody walk up to you and ask you that, you want to be ready. All right. So I have a closed circle under negative 12. Now, I am going to pick, I don't know, let me pick negative 15, which would be over here. So I'm going to pick negative 15 less than or equal to negative 12. Is this a true statement? Yes or no?
No.
Okay. Well, okay. Let me ask you this. Between negative 15 and negative 12, which one is closest to zero?
It is true.
No, no need to apologize. But like I said, we're learning as we go, and you all are doing a great job. So I want you to keep that momentum. So this is a true statement because if we compare negative 15, which is over here, to negative 12 is the number that's closest to zero. So that means this is a true statement. So because it's true, we are going to put our solutions to the left, to the left. All right. All right. All right. So we are almost through, and I have about 13 minutes. So let me knock these out. All right. Number 8. 8 is greater than n minus 5. Now, for this one, I could not transpose it. I can't switch it because that's going to give me something totally different. So you have to leave this one alone. Okay. Now, tell me what I'm going to do as it relates to this particular problem.
You're gonna add 8 on both sides.
Add 8 on both sides.
Yes.
Well, the good news is I'll give you partial credit. I do add, but it won't be 8.
5.
You're going to add 5. Okay. The reason why you're going to add 5 is because remember, you want your letter to be by itself. And if we would have added 8, it just would have been a whole nother kerfuffle. We don't want kerfuffles at 11:33 in the morning. So when I do that, that means I'm going to have 13 is greater than or equal to n. Now, do I have an open circle or a closed circle?
Close circle.
Very good, Miss Philomena. I have a closed circle. Now, Miss Philomena, I would like for you to pick a number off the number line. Oh, there go mine. Okay. Miss Philomena.
14, 14.
14. Okay. So Miss Philomena chose 14. So we are going to substitute the number 14 for the letter N. Is this a true statement? Is 13 greater than or equal to 14?
Yes.
So 13 is bigger than 14. Is that what you're saying?
It's whichever one is closest to zero, right?
No, 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 no. Don't. But I'm glad you said this, Mr. McFadden. Don't start cross-contaminating rules or cross-pollinating rules. Okay. Okay, Miss Philomena, you can put yourself back on mute. Thank you so much. 13 is not bigger than 14 on any given day when it's the positive. So we're dealing with positive numbers. Now, negative numbers, if this was a negative 13 and a negative 14, this would be absolutely correct. But remember, because we're dealing with positive numbers, 13 will never ever be greater than 14 on any given day. So because of this, this lets me know that this is not a true statement. So that means 15, 16, and all the numbers to the right of 13 would not work. So that means I have to use my numbers to the left. Okay. So, Mr. McFadden, do you see the difference between positive numbers and negative numbers and how they work?
Yes.
All right. All right. But you're still doing good. And for the record, again, I've been doing this a very long time and had a student argue me up and down about this very same thing. So I've seen it all. Don't feel bad. All right. Oh, now we get to the fun stuff. Now we get to the good stuff right here. Number 9. Who can tell me what kind of problem is this? What kind of problem is number 9?
Division.
You said addition?
Division.
Okay. Number 9 is a multiplication problem, but we will do division. Okay. So remember, number 10 is a division problem, but we're on number 9. So number 9 is a multiplication problem. Remember, you have a number and a letter put together, sign, whether it's equals or inequality with another number, we know that that is a multiplication sign. Now, Ms. Philomena, you're absolutely right. We are going to divide by -3. Now, what is my answer when I divide a 3 into a -3? What's my answer?
-1.
Very good. Now, remember, when you multiply or divide by a negative number, what do you do to your sign? And if you don't remember, just say, Miss Hampton, I don't remember.
What was the question?
The question is, or question was rather, when you divide by a negative number, what do you do with your sign?
You remove it, it becomes positive.
Well, no, you're not going to remove the sign. You're going to flip the sign. So instead of it being now a greater than sign, my sign is now going to be less than because I divided by a negative number. Okay. So now my answer is going to be X is less than -1. So what? I'm sorry, you have a question?
Forgive me if I'm wrong. Is it like a keep, change, flip thing with the
Uh
color?
no, remember, keep, change, flip, that deals with dividing fractions. So we're necessarily not dividing fractions here. We're just dividing by a negative number.
Okay.
But these are some good questions. So just remember, this only works with multiplying and dividing negative numbers. When it comes to, and let me scroll back up real quick. Come on, where that? I don't want you all to cross-contaminate and cross-pollinate rules in math. And I understand that certain rules sound similar, look similar, but you have to just kind of condition yourself to know that these rules are different and they are applied to different things. Okay, so with that being said, because we have an addition problem here and a subtraction here for number 7 and 8, I just did regular schmegular math. But numbers 9 and 10, I'm going to do the same thing. The difference is with number 9, because I divided by a negative number, I had to flip my sign. So my sign actually went from a greater than to a lesser than. Okay, so does that part make sense?
Yes, ma'am.
All right. All right. All right. So now, do I have an open circle or a closed circle? And where?
Open circle.
And
On
where my open circle is going to be where?
on -1.
At -1. Excellent job, Ms. Philomena. All right. So we have -1 with an open circle. Now I am going to pick, let me pick 2. I'm just picking the number from the number line. So I'm going to pick 2. Is 2 less than -1? Is that true?
No.
No, it is not. Now, if I were to pick a -2, whoops, what? I were to put a -2 here, that it would make it a true statement. So because I did that, my numbers to the left of -1 would suffice. All right. Okay, we rocking and rolling. We cooking with fish grease. All right. Number 10. Now, number 10 is a division problem. So because it's a division problem, that means I am going to do the inverse operation and multiply. Okay. So the good news is I'm only dealing with positive numbers, so that works out. And when I do that, we know 3 times 3 is 9. So therefore, n is greater than 9. Okay. Now, I know I have an open circle because there is no line under my inequality sign. Okay. I'm going to pick a number. Let's pick 7 just for fun. Now we know that 7 is not greater than 9. We know that. Did you have a question, Miss Philomena?
Yes, ma'am.
Yes, ma'am.
Number 10, are we still going to flip the sign or leave it in the division?
No, ma'am, you do not flip the sign in this one because we are not multiplying by a negative number. Okay, so we have 3 and 3 are positive numbers. Okay, so because those numbers are positive, we would not have to flip the sign. You only flip the sign when you are multiplying or dividing by a negative number. But the good news is we only are dealing with positive numbers here. So that's the good news. And also, when we look at our number line, we have nothing but positive numbers. So that can also be a trick to or a technique that you can use when you look at the number line. And if all of your numbers are positive and you come up with a negative answer, that means you probably did something wrong. So I would suggest that you look at your number line just to make sure that you come up with at least a positive answer of sorts. Okay. That's not always going to be the case, especially when you have a problem like number 9 that has both negative and positive numbers. Okay. So again, making sure that you know how those integers work is very important. Now, again, we know that 7 is not greater than 9. We know that. So any number to the left would not work. Now, if I pick 10, on the other hand, 10 is greater than 9. So because 10 is greater than 9, all my numbers over here. Ow, ow, ow. All right. Okay. I know I got 60 seconds, but I know I ain't going to be able to do both of these problems in 60 seconds, so just bear with me. All right. Number 11. Number 11 is a division problem. Matter of fact, number 11, cursor. Number 11 is just like number 10. The only difference is now we are going to multiply by a negative number. So when we multiply by a negative number, now we have to flip the sign. So we have k over 4 is less than -4. A negative times a positive gives me a negative. However, that's right.
16.
Yep, that's correct. And now my sign is going to be flipped because I multiplied by a -4. Okay, so when I multiply or divide by a negative number, I flip my sign. All right. So do I have an open circle or a closed circle?
Open circle.
Excellent job. I have an open circle and it's over the number 16. Now I'm going to pick a number. I don't know. Let me just go with 14. Negative 14, excuse me. So is negative 14 greater than negative 16? Is that true?
Yes, ma'am.
It is true. So because it is true, that means any number to the right of negative 16 would make this true. All right. So we have one more problem, and then that's going to be the end of it. We're going to be finished. All right. Now, okay, let me make sure I have enough room. Okay. All right. So, okay. So, Miss Philomena, you can go ahead and put yourself back on mute. Thank you so very much. We just want to make sure that the people that's watching the playback video can hear everyone clearly. Okay. Now, we have this last problem. This, again, this problem is a multiplication problem. So because it is a multiplication problem, we are going to divide. Woo. And because I'm dividing by a negative number, that means my sign is going to be flipped because I'm dividing by a negative 9. So I have x is going to be less than or equal to 10. So again, a negative divided by a negative gives me a positive. Okay, so again, we're just reinforcing those integers. All right. Now, I am going to have a closed circle. The reason why, again, is because I have this line under my inequality sign, and that lets me know that 10 is a part of that solution. Do you have a question, Miss Philomena?
No, no, ma'am.
Oh, okay, okay. I just wanted to be sure. Okay, so now what I'm going to do is I'm going to pick a number. I can't pick 10 because 10 really don't count. So I am going to pick 11 just for fun and giggle. I know that 11 is not less than or equal to 10. I know that. So because I know that, that means 12 is not an option, 13 is not a solution. Any number to the right of 10 is not a solution. So that means all my numbers to the left are solutions. Do 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 do. La 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 la. All right. Now, if I'm not mistaken, was there two sheets that came with this sheet right here? Or was it just this one? I can't remember.
It was 2 sheets.
Okay, so now the good news is we just finished this whole entire first sheet. The better news is that you're going to do the second sheet all by yourself because practice makes perfect, and that's important. So as soon as this video, as soon as I can get this video uploaded for you all, you can go back and reference this video to help you with the remaining problems. So you all have 13 through 24. All right. So half of the work has already been completed. Now it is up to you to do the rest. And I know you can because you all did a good job today with explaining and telling me why certain things are the way that they are. All right. So that this is your homework assignment to finish up the second page, 13 through 24. And you all do have your answer sheets. So please make sure that you check those. For anyone that's watching this playback video, the link will be in the video that I'm going to post at the end of this broadcast. Okay. So just make sure you click that video and then you click the link in the pinned comment section and you can have the same worksheet as well. And it is a PDF file. So if you have printer access, you can print it. You can have a hard copy. All right. So, how do we feel about today's review? Do we have a better understanding of it? Does it make sense?
Yes, that's good. Makes sense.
Okay, excellent, excellent. What about you, Mr. McFadden? How do you feel?
I mean, it's starting to make sense. It just with the keep change flip. That's what keep getting me confused. So it's just,
Okay, okay. And like I say, remember, I get it. I know in math it's a lot of rules, and you got to apply rules to certain things because everything ain't for everybody. That's included in math. But just keep in mind that once you understand the process, everything else is easy because remember, inequalities are nothing more than equations with an inequality sign. So it's I think you all have the solving part down pat. I think it's the graphing part that kind of is like, it get that bothers me. So we will continue to practice more on how to graph these inequalities. But you all did a really good job with solving them. So that's half the battle. So that's good. Okay. Robert, I don't know if you're still with us, but if you are, how do you feel about today's lesson?
he said he had to go to work, Miss Ham.
Oh, okay, okay. Okay. And that's probably that little chime thing that I heard. But hopefully he, understood and got everything. All right. So I'm going to go ahead and stop the screen share. And again, your homework assignment is to finish up that second page. Um, please text me before tomorrow. Please text me and let me know if you need to go over any of those problems. We probably won't be able to do all those problems, but we can probably go over a couple because I want to make sure that we can get the opportunity to do the two-step inequalities as well as multi-step inequalities. Okay, so I want us to, try to build upon these things. Okay, so are there any questions? Are there any comments? Any concerns? Do, 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 do. Okay,
No, man.
well, no. All right, well, no news is good news to me. So,
It makes you feel better.
thank you so very much. I'm getting ready to, take better care of myself so that I can be back to 100% for you all tomorrow. To anybody that's watching this playback, please keep me in your prayers. I'm not really feeling the best, and I tried to end this video a little early, but whenever you miss Hampton's class, that never seems to happen, but that's okay. So, with that being said, I'm going to go ahead and doctor up on myself so I can be back to 100% for you all. Again, thank you so much to everybody that came to class today. I will be sure to definitely give you all your credit for today. And we will go over the second part of that worksheet tomorrow. So just have everything ready. And again, if you have any questions, you know where to find me. I ain't going nowhere. You know where to find me. So with that being said, I pray that you all have a wonderful and blessed Wednesday. Please continue to be safe. Continue to adhere to the rules as it relates to social distancing and everything else that is happening. Just protect yourselves, protect your families, and as Hampton loves you, there's absolutely nothing you can do about it. And until tomorrow, Lord willing. Bye.